We have with us today Dr. Pat Malone, who is a professor of urban studies and American civilization, and he's director of the Urban Studies program at Brown University. He is co-author of The Texture of Industry, an archaeological view of the industrialization of North America, and he is author of The Skulking Way of War, Technology and Tactics Among the New England Indians, also published by Johns Hopkins. So they gave me that in fine print, so I did the best I could. Sorry, Pat. Anyway, all of us who work at the national park on issues dealing with the Lowell Canal system constantly use Pat's work as a reference and a guide, and he's been called more than once for some advice on one arcane issue or another. So we are very pleased to be supportive of Pat's new book, and glad to welcome him to speak to us this afternoon. Pat Malone.
Well, it's certainly a pleasure to be here at Lowell. Many of the people in this room actually helped me with this book, and I think it's really appropriate for me to kind of kick off the campaign for the book with a talk here in the National Park. This is the book published by Johns Hopkins University Press, and it's available in both paperback and hardcover. The idea for Lowell may lie in a utopian plan by David Dale and Robert Owen for this community, New Lanark in Scotland. Nathan Appleton saw this model industrial community in 1810 while he and Francis Cabot Lowell were both in Britain. And the whole idea of New Lanark was that an attractive and comfortable environment would actually improve worker productivity. This is the map of New Lanark at a somewhat later period, about the mid-19th century, but it shows the particular canal development that was used here, and which I think influenced Nathan Appleton. That is that there's a dam, there's a power canal that runs from the dam downstream, parallel to the river. And between the power canal and the river, there are a whole series of mills, multiple mills, all being driven by this one power canal. This was the largest water power site in Britain, but Lowell would make this site really look minuscule. Waltham was the testing ground for the later industrial development in Lowell. Mills built in 1813 and 1817 for the Boston Manufacturing Company were on a power canal that was parallel to the river. This plan was similar in conception to New Lanark, and the success of textile operations in Waltham led to a search for a manufacturing site with much more water power and with room for development. So these are the two mills. You can't see the power canal, but it's running in front of those mills. And here is the dam and the falls on the Charles River. But this was a site that really had inadequate water power. Not very far away, however, was a site that had much more potential. The great city of Lowell exists because of the Pawtucket Falls of the Merrimack River, which are 27 miles from Boston, as you all know. The falls had the potential to produce almost 10,000 horsepower year-round, and there was a drop here of some 30 feet. Pawtucket, or more properly East Chelmsford, Massachusetts, was the site of colonial farms and small-scale mills. The falls were spectacular, but they seemed impossible to harness and hindered transportation on the Merrimack River. In 1796 and 1797, the proprietors of locks and canals built an artificial waterway around this sharp drop on the river. And you see the rapids here, which are still in place, and the falls were really jagged rocks and rapids. Industrialists known to historians as the Boston Associates gained control of this failing transportation canal in 1821. So the Pawtucket Canal, which the proprietors of locks and canals had constructed as a way to go around this obstacle, was not doing very well by 1821. And these new industrialists, these investors who we call the Boston Associates, quickly turned the old Pawtucket Canal into a feeder for a system of power canals that would serve industry. The concept, I think, is really visible here. This is Cohoes, New York, and the falls of the Mohawk River, where there is a dramatic drop of some 80 feet. And Lowell was really an inspiration for the development of Cohoes. But here we see all of the water diverted. So here is the falls with nothing going over it. And instead, the river is being diverted into a power canal. And the water is staying at the upper level above the falls. And it's then being taken a considerable distance downstream while the river continues to drop, giving you even more potential power. And finally, we see mills in the distance. So this is the same type of concept that the Boston Associates hope to use in Lowell. In 1821, the situation in this area was shown on a map by Hales. And this particular map identifies the falls. You can see the Pawtucket Canal, which goes around the falls and into the Concord just before its junction with the Merrimack. And there's also an interesting feature on here. There's a contour line, which is the height of the river above the falls. And that's really important in the planning of the mills that would be put in place here. The Boston Associates secretly bought most of the land between the Pawtucket Canal and the river. They then formed a new corporation, the Merrimack Manufacturing Company, to manufacture textiles. And they placed its first mill to use the full drop of 30 feet. So they're putting that mill over here, and they're going to use this transportation canal to feed a series of power canals. The Merrimack Manufacturing Company, with this full drop, had what they considered an ideal location. But they had plans for up to 60 mills in all. So this is really going to be an enormous transformation. This particular image came from the Center for Lowell History. And this next map came from the Lowell National Park collection. This is a map of Lowell in 1825. Chuck Parrott, who's here today, was co-supervisor with me of the Historic American Engineering Record survey in Lowell. And we discovered this map in the basement of the Boot Mill and in the operation that was then known as Boot Hydro. And this is a map that conveys the canal system, not only as it was in 1825, but as it would be in all of the construction that was planned for the immediate future. And in fact, it took them until 1836 to complete all of the canals. The falls are here, the Pawtucket Canal is here, feeding this network of power canals. This planned system is not the simple parallel plan that we saw at Waltham and we would see later at Lawrence. Instead, it makes use of this existing Pawtucket Canal, and it ends up with a rather complex network of water power canals on 2 levels. In 1824, just before that map was produced, they had begun to tentatively plan for a change in the operations in Lowell. In 1825, the Merrimack Manufacturing Company decided to sell land and lease Waterpower to other corporations. In 1824, they were still thinking about expansion and perhaps considering operating all of the new mills themselves. But they decided that they would set up the old proprietors of locks and canals as a land agent, construction firm, machine builder, and leaser or lessor of water power. They were going to be leasing Waterpower to other corporations. And the first sale was to the Hamilton Manufacturing Company. And this plan represents the ideal layout of mills, but on a relatively small scale. So we see a drop created here at the swamp blocks, which would be a 13-foot drop, from an upper-level Pawtucket Canal to a lower-level Pawtucket Canal. And we see a new power canal, which would be called the Hamilton Canal, which would feed an entire set of mills, both the Hamilton Mills in 1825 and the Appleton Mills in 1828. And we also see the planning for boarding houses, which would be across the canal. So this was a rational layout. We also can see their plan to constrain the rather unruly Pawtucket Canal and to ideally narrow it down to about 60 feet wide and 8 feet deep. So this ideal system involved 2 levels. And Chuck Parrott produced this drawing for me to demonstrate the 2-level concept. And I think this is the first time someone's produced a schematic that's easy to understand that shows you how the 2-level system worked. Essentially, you bring the water through an upper-level canal, which is carrying it at the same level as it would be in the mill pond above the falls. You bring that to the first mill, and the water would go onto a vertical water wheel in this case and drop 13 feet. It would then go into a lower-level canal, and the water would then be used again. It would drop 17 more feet through the lower-level canal and finally discharge into the river below the falls. So this is a total drop of 30 feet, but only the Merrimack Manufacturing Company was getting the full drop. Everyone else was going to get either 13 or 17. The engineers in Lowell determined the flow rate that would provide the same amount of power on each level if you leased the power by mill powers. 1 mill power was defined as the amount of power used to drive the machinery in the second mill at Waltham, a mill of 3,584 spindles that used about 54 net horsepower. So the engineers found that for the full drop at the Merrimack, you needed 25 cubic feet per second. For the 17-foot drop, you needed 45.5 cubic feet per second. And for the 13-foot drop, you needed 60.5 cubic feet per second. And each of those flow rates would give you 1 mill power. They're not simply proportional to the drop. They show that the fair distribution included consideration of the slightly different efficiencies, averaging about 64%, found with high breast wheels of varying diameters. I worked on this drawing with the National Geographic for their Historical Atlas of the United States, working with an illustrator from Scientific American. And this shows a typical Lowell mill of the 1840s. And we can see here the 2 breast wheels, which are being automatically governed by a flyball governor, which responds to changes in power demand in the mill to keep the speed of the shafts in the mill running at the ideal speed. In David Macaulay's book, Mill, and I consulted with David on that book as well, there's some really excellent diagrams that explain how the flyball governor system works. You also can see in this drawing the main belt drive, which is a system of transmission of power from the breast wheels in the basement up to the machinery on the floors above. And here you see some of that machinery, and you can see that layout. And once again, you can see this diagram, which is based on a drawing by Ithamir Beard, who worked in Lowell in the 1830s. Now, we also have a model in the boot mill of the boot mill, or one of the boot mills, in the 1840s. And I worked on this model with a number of other scholars, and we think that we had figured out exactly how many machines of each type were in the mill, how large the pulleys had to be to make all of the speeds that were appropriate for manufacturing. And if you go to the boot mill, you can really see the full system of production with this model. Map of Lowell in 1832 gives you a good sense of how quickly the city was growing. This is a city that begins as a rural area with small country mills and perhaps 200 people in all in 1821. And by 1826, when East Chelmsford becomes a town called Lowell, there were 2,500 people. By 1836, when Lowell became a city, it had expanded in size to 17,600 and was one of the fastest growing cities in the United States. By 1850, there were 33,000 people, and it was the second largest city in Massachusetts. It went on to grow throughout the 19th century, reaching 90,000 in 1900 at the turn of the century. So this map shows you that the canal system was right in the middle of the community, strongly affecting the urban plan and the daily lives of the citizenry. Here in this map, you see all the canals and mills that would be built by 1836. The map itself is 1832, but it shows you the Eastern Canal, which was the last of the canals shown on the 1825 map, and it would not be completed until 1836. You also see the private construction that was helping to make this a boom town, but not a true company town. The textile corporations were tremendously influential, but other people who were not working for the corporations were coming to Lowell. Lowell's power canals were edges or barriers obstructing communication. The canals forced lengthy detours to available bridges, cut off neighborhoods, and created physical and social boundaries in the city. The Irish neighborhood in the Acre was in many ways the other side of the tracks, but it was literally the other side of the Western Canal, which branched from the Pawtucket Canal. You can see the western here. If Lowell can be considered a planned industrial community, it's only because the city's founders planned a complex canal system which incorporated an existing transportation canal. They did not work with a blank sheet of paper to produce some ideal geometric layout. They had to deal with the arc of the Pawtucket Canal and the bend of the river. Several key highways and river crossings were already in place. At first, they seemed to ignore the challenges of creating a real community. The planners' only concern seemed to be the siting of power canals, mills, corporate housing, and whatever new roads were necessary to serve these features of the emerging industrial landscape. Private development would take place where there was room, on the land that the corporations didn't need, such as this area down here along the Concord. The dam that they created in Lowell was at the head of the falls, and the first one that really reached all the way across the river was in 1826. This painting at the Harvard Business School can be dated exactly because it shows a particular construction phase on the dam. In 1830, they improved the dam and changed its arrangement somewhat. And in 1832, they added some granite headers to the top of the dam. So what we see here are the granite headers being added. I'm sorry, 1833. They raised the dam 2 feet with the addition of these granite headers. The dam, at this point, stilled the water in the river for 18 miles upstream. creating an enormous mill pond. It also flooded wheel pits in Nashua, New Hampshire. And it hurt the runs of fish in the river. So despite the fact that they put a fishway in this dam, as they were adding these headers, the fishway never really worked very well. And it was in place from 1830 to 1854, and then they closed it up until they were forced by the state in 1868 to add it again. The Historic American Engineering Record produced a number of engineering drawings of particular features of the canal, but it also produced a set of schematics, which have been used in a number of publications. And this is one of the system maps or schematics for 1836. And what we've done here is to tint this so that the lower level is dark blue, the upper level is light blue. But here you see the two levels that we talked about in the previous diagram. The corporations in Lowell created one of the most complex power canal systems ever built. Engineers designed the system on a radial layout with two levels and drops, as we've seen, of 30, 17, and 13 feet. And this shows the first stage of development up to 1836. The two-level system had to be in dynamic equilibrium to make full use of the power from the river. Waste occurred whenever one level used more power than the other. On this diagram, as we can see, the upper level in light blue is feeding the lower level in dark blue. The mill complexes, as of 1836, are circled. Water entered the river and flowed down the Pawtucket Canal to the power canals on the upper level. And discharge from those, except for the Merrimack, fed the lower level mills. So you would have, for instance, water coming in at an upper level going through the Hamilton and Appleton mills and then into the lower level Pawtucket and running down to the eastern, and there it would feed the Boot mills, and from the lower level Pawtucket, it would feed the Middlesex mills, which was the only complex on this system that was also drawing power from the Concord River. The Concord River has had 3 drops in this period and had its own much smaller canal system, the Wamasett Canal. Water power was far more important than steam power during the initial stages of the American Industrial Revolution. And it was the key factor in the siting and physical development of many American manufacturing cities, including Lowell, Lawrence, and Manchester on the Merrimack River. The 1880 census called the Merrimack, quote, the most noted water power stream in the world, unquote. As Thoreau said in 1839, there was a city on each successive plateau, a busy colony of human beaver around every falls. Construction of mills, housing, and canals by the Lowell corporations was virtually a continuous activity for decades. However, soon after the Boston Associates had their first mill in operation, they began to soften the look of the development that they were creating. They did that with a program of tree planting. They deliberately reestablished a connection with nature by creating an artificial but green landscape in the corridor leading to their mill yard. Many of the founders of Lowell were avid horticulturists. And this shows the scene before there's much planting and after they've removed some of the earlier trees. And this is on Lower Dutton Street. And we see the Merrimack Canal here. And this is also one of the few views of a boat in the Merrimack Canal, demonstrating that the power canal system also retains a transportation capability, and that was particularly important in getting building materials to the mills and in getting lumber or logs to some of the sawmills that eventually located on the upper part of the Pawtucket Canal. So near this particular image, in 1840, William Boot built a mall And a mall is a landscaped park, in effect, at least as the term is used in Lowell. Usually it means a shaded passageway between trees. But the Shattuck Mall that William Booth built in 1840 was really amazing. Chuck Parrott found the actual planning list at the Baker Library at Harvard, and he identified 115 trees that were to be planted here of 43 species and 88 shrubs of 38 species, all in the relatively small Shattuck Mall. The planning on the upper section of Dutton Street was already quite advanced by the late 1820s. This is the same date as the other view, but the lower Dutton Street in 1834 was still not landscaped. The upper section along the Merrimack Canal on Dutton Street had a line of street trees and a line of trees along the canal. A contributor to Lowell Offering in 1841 was impressed by the effects of these corporate landscaping programs. Quote, "Within a short time, shade trees have been placed around the different corporations and along some of the canals. Even double rows of trees have been placed, forming a cool and delightful retreat. Many pleasant hours have I spent beneath their shade," unquote. People in Lowell had used the 38-foot wide strip of land next to the Merrimack Canal here as a promenade since the late 1820s. The term mall was applied here as well, and here it really fits the shaded walk or public promenade. And you can see Dutton Street here, the line of boarding houses for the Merrimack Mill, and the Merrimack Mill at the end. You can also see the rail spur that ran down the street. And here to the right, just off the image, is the mall of trees along the canal, and here are the protected street trees. And these are growing relatively slowly because the Boston Associates preferred elms. And elms were the great tree of the 19th century. So much of their planning involved rows of elms. In this postcard, you can see the mall along Dutton Street, and you also can see a similar mall on the other side along Ann Street with the Merrimack Mill in the background. You also can see that postcards were usually colored in Germany, and perhaps in Germany you spell canal C-A-N-N-A-L, but not in Lowell. The developments along the Merrimack Canal were being carried out first by Kirk Boot and then by William Boot and then by this man, James B. Francis. And he's working closely in this particular case with private citizens. In 1844, several residents of Ann Street took steps to protect their view. Go back and look at that. Ann Street's over here on the right. And they wanted to protect their view and the green surroundings on the east bank of the Merrimack Canal. Benjamin French and his neighbor, Charles Carleton, persuaded Francis and the proprietors of locks and canals to grant them trusteeship over the strip of land at the canal's edge so they could keep it, quote, as ornamental ground forever. The land so designated was, quote, dedicated and set apart by the grantors for the purpose of beautifying and ventilating the city. So in many ways, this corporate landscaping program is really providing a public amenity. And James Francis, who came from England to America in 1833, when he was just 17 years old, is one of the most enthusiastic of the horticulturists in Lowell. He joined the proprietors of locks and canals in 1834, just a year after he arrived in America, and he was only 18 at that point. When his mentor, George Whistler, the chief engineer, left in 1837, Francis became the chief engineer. He was only 22 years old. In 1845, there was a major change in the ownership of the power company. The users of the water took over the proprietors of locks and canals, buying back all the stock and redistributing it to the manufacturing companies in proportion to their water leases. So the more water you used, the more ownership you had in the proprietors of locks and canals. They also sold a great deal of their land in the city. Francis became the agent or chief operating officer of the power company during this corporate restructuring. He also kept his status as the chief engineer. His first major project as agent was buying up the northern lakes that fed the Merrimack and then constructing a new canal for the city of Lowell. So this is a map that I had produced for my book. One of my students drew this. And it shows the Merrimack River, and you all know where you are. And you can see the river being formed at Franklin, New Hampshire, with the flow coming from Lake Winnipesaukee, and with the Pemigewasset flow coming down from other lakes, including Squam and Newfound. So individual industrialists in Lowell and Lawrence came up with the idea of buying lakes in New Hampshire as reservoirs for the Merrimack River. The Merrimack River flow was extremely variable. And in the summer, you couldn't be guaranteed that you'd really have enough flow to satisfy the needs of this growing industrial city and the needs of Lawrence, Massachusetts. So in 1846, figures from Lawrence, which was just under construction at that time, and from Lowell, began to buy up the lakes in New Hampshire. And they ended up buying up over 100 square miles of lakes by the end of the 1850s. They put dams at their outlets, and they converted them to reservoirs for water power. And they did this to ensure much steadier flow, even in dry seasons. Francis installed a telegraph that went up to the outlets of the lakes, and he could order them to release water from the lakes in New Hampshire. So if Francis sent a telegram from Lowell and said to open the gates on Lake Winnipesaukee, water would flow out. And they could do the same thing up at Squam Lake. And you have to think about Squam Lake, which is Golden Pond in the movie. So you'd have a loon floating on Squam Lake one day, and the telegraph message would arrive. They'd open the gates, and the loon's elevation would slowly start to drop because the water was coming down to Lowell. The first phase of water power development, as we've seen, was completed by 1836. And there were then 26 mills on the system. 10 years later, the canals were essentially the same, but there were 31 mills on the system, running 2,228 spindles and 6,308 looms. And by that point, almost 30,000 people lived in the city. And the proprietors of locks and canals were then leasing a total of 91 mill powers, which is substantially more than their original estimate of 60. But that was still not enough to meet the demand, particularly in the summer. And many mills were using more than their leases allowed. The system was strained. The solution to this water power shortage involved improvements to the entire drainage basin and construction of another canal and an underground feeder. So that canal is this northern canal, which they had been planning since 1839, but which they began to build in 1846 and 47. And they also built in 1848 the Moody Street feeder, which was a shortcut from the Western Canal over to the Merrimack Canal. So once the Northern Canal was in place, this large waterway could carry water much more efficiently with less drop in the water. Friction head loss was a major problem in Lowell. Water would brush against the sides of the canal, and the water level in the canal would actually drop. So with a more efficient canal coming in, and also with the Pawtucket Canal still in use, they could lower the current and reduce the friction head losses. They would bring the water in the northern canal and supply the Tremont and the Suffolk and the Lawrence at this point. Then they reverse the current in the western canal and send it down to the swamp locks, where it would join the flow from the Pawtucket to satisfy all of these mills. And they could, after 1848, bring it underground, under Moody Street, over to the Merrimack Canal. The system could really use this new development, but Francis had to be sure that the mills would be willing to let him pond water at night behind the dam. The corporations had to promise that they wouldn't run at night so that they could make this enormous investment in construction. And that way they could draw the pond down somewhat during the daytime, and at night it would refill. Once Francis had this agreement, and once he had control of the northern lakes, he rebuilt the dam at Pawtucket Falls, and he added this canal. The total project cost more than $500,000 between 1846 and 1848. And the total power went from 91 mill powers to 137 mill powers, an increase of over 50%. And if we really think about the potential power here, with improvements in turbines and improvements in other features of the system in coming decades, this amounted to almost 10,000 net horsepower. The map shows the Northern Canal in place, and we see how this really could improve the operation of the entire system. The Northern Canal was James Francis's greatest professional triumph, and it remains one of the landmarks of American engineering. This 1847 dam that you see here channeled water into the efficient Northern Canal through a gatehouse with the first operational turbine that Francis designed. Mixed flow turbines today are still called Francis turbines. He and Uriah Boyden, who was also from Lowell, were instrumental in the development of the hydraulic turbine. The gatehouse is an important landmark, and if you look at its design, you see a feature here, which is a curved corner. And that's really functional streamlining for floods, so that trees or ice during a flood would not break off the corner of the building. Within this structure were a whole series of gates, 10 major gates that could allow flow into the Northern Canal. This is also a barrier against floods because you could close these gates as well. And what Francis really wanted to do was to operate this very efficiently so that if water was scarce, you could even close it over the lunch hour. The gates were really large and heavy, and to do that manually would have been difficult. And Francis wanted to experiment with a new type of turbine anyway. So what he does here, in addition to building this gatehouse, is really to create what I think is today America's oldest industrial research laboratory. It has built-in features for hydraulic experiments on turbines, weirs, and nozzles. The experimental turbine that Francis installed here to run the gates could adjust those gates very, very quickly, even, as I said, shutting them at noon. So this is a drawing done during the Historic American Engineering Record Survey, and it shows the gatehouse, and these are the gates. And then this is the turbine, the first Francis turbine. and then a main belt drive system that controls the gates. I was kind of curious whether that Francis turbine might really still be in that gatehouse. And after doing some research in the mid-1970s, I couldn't find any evidence that it had ever been moved. So I decided that I would go look at it, and I set a day that I was going to do it, and I do what I say, even if the Patriots end up in a playoff game during the call. So turned out that day was a flood. It wasn't a good day, it was cold, and I needed some help to go down and investigate this. So I got two Brown football players who needed extra credit in my course really badly. And during a flood, we went there, and we went down into the pit, and when I got down there, I realized that the opening of the pit was armored. And I wondered why it was armored, and I thought about it. The river's actually much higher than the pit. So there was the potential that the pit might be pressurized. But I could hear water flowing, so I assumed that really water was flowing out as fast as it was flowing in. And so we opened the pit and went down, and this is the leaking valve with the Merrimack River high above. And this is the wheel pit. I dived down, and there was the turbine, still there. I later went back with Chuck Parrott, and he and I went in there with measurements that we'd taken from the drawings, some of which are actually out here, that Jack Hurley brought today. And we confirmed that it was the original Francis turbine. This view shows the falls. Actually, this is the falls. Here to the right, with the dam leading directly to the gatehouse, and then with the northern canal. This is the gatehouse, and here's the northern canal. And then that runs downstream, and you can see the island that's created between the canal and the river. And then you see the Great River Wall, because in order to put this canal through, not only was tremendous excavation necessary in this section, but you had to build a wall, in effect a dam, that could hold the water more than 30 feet above the river. So here Francis built the Great River Wall, which was 36 feet high, and he landscaped it with elms and other trees and shrubs. This is one of the plans. This is a plan from 1848 by Francis, where he's really acting like a landscape architect, designing the mall. And this is the Great River Wall viewed from the Moody Street Bridge many years ago, now in better shape than this. Francis is planning the mall because he wants people to promenade, to really take advantage of the natural setting and of the sublime. And these days, sublime meant really kind of awesome or frightening view. So you would go through the landscaped mall and then out onto this Great River Wall, which was one of the most impressive vistas in America. And the construction of this was tremendously difficult. This river wall required up to 1,000 men working on the canal. So this was a construction project that rivaled almost anything else in America. A postcard actually shows people promenading on the Great River Wall, and documentary accounts of the enthusiasm which people displayed for the walkway are supported by a wealth of photographic evidence. There are numerous stereos and postcards that show people happily promenading on the various sections. And you can see here the dramatic rapids in a high water situation. But while people were promenading, And on Sundays, the mill girls of Lowell would put on their best clothing and promenade on the canal. Other people were working, because the one day that you could really clean the canal without causing a problem for manufacturing was on Sunday. So workers, many of them in the mid-19th century, Irish workers, would be down in the canal removing mud while the mill girls promenaded above. And that was noted in some of the labor literature of the period. That's actually, I think it says 1897. But this is a little later. We don't have a photographic image from the mid-19th century of this actual work in the canals. The Locks and Canals photograph collection, most of which is at the Lowell National Historical Park, includes great images like this. And this particular one, I believe, came from the Center for Lowell History, which has a number of great images as well. This photograph shows you a slightly different view, and it contrasts this. Here you can see the spring freshet with water wasting over the dam. Francis just hates that. Any water that goes by, any water for a fish, for instance, is wasted water. So what he wants to see is this, which is closer to the image I showed you earlier in Cohoes. This is all of the flow of the Merrimack coming through the canal. And at night, this would continue because they would fill the mill pond at night. So sometimes it might be weeks before there would be any flow of water through the rapids. Now, people who did promenade on the Great River Wall were really astounded by the view. And D. Hamilton Hurd explained the appeal of the Northern Canal and its walkway. He said, not only for solidity and strength alone is it worthy of our admiration, but its green banks adorned with double colonnades of trees and its attractive promenades with the waters of the Merrimack dashing by afford to the eye a very pleasant prospect and display to the visitor a picturesque scene of no ordinary beauty. All of us recognize that industrialization came with social and environmental costs, some of which we will continue to pay for centuries. But this was another face of industry, a softer side that made room for flowering plants and green space. In addition to landscaping company property, engineers and industrialists played key roles in the urban parks movement. The owners and managers of the major corporations in Lowell were concerned about their public image and about the aesthetic and recreational aspects of the built environment they were creating. Most believed that workers would be healthier and more satisfied with their employment if they had opportunities to stroll down attractive walkways and breathe fresh air. So that view of the efficiency with which the water was delivered also applies to this view, where Francis is trying to establish ways to measure the flow of water with great accuracy. So in his book, Lowell Hydraulic Experiments, which he published in 1855, Francis shows a number of experiments with turbines and also with weirs. A weir is really an aperture over which water spills. And you can see the weir here with water spilling over it. Francis, in his experiments, wanted to actually test the engineering theories of the age. He didn't trust theoretical engineering. He believed in empirical testing. And he also believed in testing full size. So he did experiments that were incredibly expensive. Such as this one at the lower locks, where he converted an entire chamber at the lower locks into a measuring basin. And this is the lower lock chamber that will measure water. And what he does is let water flow over a weir for an interval of time. And he can precisely determine that interval of time with this gate that he can open and close rapidly to cut off the flow of water. And from that gate, there is an electrical line, in effect a telegraph line, to this small building. And inside it, an operator with a marine chronometer can measure the exact amount of time that water flowed over the weir. They then can measure the water in the lock chamber, and they can measure the exact height of the water over the weir using this hook gauge that Uriah Boyden developed. And with this, Francis is able to refine and improve the weir formula, which is really the key formula in hydraulic engineering. And it's this formula that allows him to test turbines, and it's this formula that allows him to develop methods for measuring flow on the canal system. The weir formula used by Francis is still considered the best and is still in regular use by hydraulic engineers and hydrologists. Measuring water was a critical part of the operation of the canal system. It allowed locks and canals to provide surplus water above and beyond the leases. Francis could give you extra water most of the year. The leases were quite conservative. The 139 millpowers was what they could guarantee all year round. But for much of the year, you could have more water. In fact, the average amount of extra water used was somewhere between 24 and 34 millpowers. But if you're going to give people that extra water, Francis wanted to charge them for it. And he needed to develop a system to measure how much water each mill complex was using. This photograph shows a demonstration of the method that he developed in Lowell. This is an American Society of Civil Engineers meeting in Lowell in 1878. And they're on the Merrimack Canal, and these are the transit beams that are used in a lined wooden flume. And what this guy is going to do is take this hollow tube, and he's going to put it in the current, which apparently took considerable finesse, and then it's going to float down, and they're going to time the transit between one of these beams and the other beam. They're exactly 100 feet apart. And by sending this tube down about every 1.5 feet approximately across the width of the canal, and by measuring all these transit times, they can calculate the speed of the tube. And for various reasons, very complex physics, the tube floats at almost exactly the same speed as the current of the water. If you know the current, and you can calculate that, and you know the cross-section of the wooden flume, you can measure exactly how much water is flowing down to the Merrimack Mills. And in this way, he can charge you for the extra water. This is water really being used as a commodity. So I had one of my students draw an image to explain this, and it's explained in the book. I put it in the sidebar so not everyone would have to deal with it. In fact, I put the entire set of hydraulic experiments and flow measurements in a separate chapter. So if you read the book and don't want to learn a lot about the hydraulic engineering, you can follow the narrative, I think, quite well and just skim chapter 4. Also, this was the only way my editor would let me put this explanation in the book. He said, put a line around it and warn people they don't have to read it. So this shows the tube measurement. And we know this works because Chuck Parrott and I built a model of this, and we actually tried it at the Zongas Industrial History Center. And we used soda straws and small lead shot. And on a tiny scale, we tested it, and it really works. You can measure flow beautifully. And then you plot your calculations of speed, and then you figure out the area under the curve, which is another complex operation. And this is one part of the engineering where women were sometimes involved as calculators. They were considered very accurate. So that's the flume and float measurement system, which we're going to talk about in a later national park program this year. And this is one of the features that I think the people of Lowell appreciate most. This is the Francis Gate, which saved the city in the 1852 flood. So this is called the Guard Locks Complex, and the Francis Gate is here, a huge portcullis gate hanging from a metal shackle over the lock that leads into the Pawtucket Canal. And then on the other side is the sluice gate house, where flow to operate the mills is in continuous operation. But this gate is only meant to be used in an emergency. And Francis really kind of hesitated to do this. He had a problem with a flood in 1847 while he was building the northern gatehouse and the dam. And then in 1850, there was another flood. And at that point, there was some damage done to the bridge at the falls. And the owners of the bridge began to question whether the construction of the dam and the gatehouse was aggravating the flood situation. And at that point, I think Francis became a little worried about the liabilities. And he decided that he would build this huge gate, white pine timbers that were pressure treated in a process called burnitizing, which protected them from decay. In fact, they're still there, so that works pretty well. The process itself is somewhat toxic, but we wouldn't be using it much today. But burnitizing and kyanizing are two things that were done extensively in Lowell. Chuck and I want to do an article about it because it's really an interesting set of processes that work fairly well. But Francis erected this in 1850, and this was a costly operation. This gate weighs about 20 tons, and people really thought it was totally unnecessary. There hadn't been a great flood of the type that would destroy the locks since 1785. But Francis, in looking at the 1785 data, realized that if he ever had a flood that was as bad as the 1785 one, with the new construction of the dam and the gatehouse and the bridge, water would rise even higher. So he decided that he would protect the system with this gate, which people referred to as Francis's Folly. Everyone in Lowell knows that he put this up in 1850, and in 1852, that great flood arrived. So he timed it just right. And so Francis is the savior of the city. If the great flood had come in 1849, we might be looking at him in a slightly different light. But this is the gatehouse that he built. And that gatehouse and portcullis gate saved the city in 1852. They put it away and didn't think much about it, but it was there. And in 1836, they had to run down and cut the metal shackle again. And once again, gravity did its work and simply dropped this gate. It's a relatively foolproof gate across the lock. And the 1936 flood was even worse. The 1852 flood was 14 feet 1 inch, and the flood in 1936 was about 5 feet higher than that. So this really tested it. In fact, they had to sandbag the top of the dam here to really be sure it was going to hold. And here you can see water spraying through the gate. Now, we had a flood here in 2006, and it was within 18 inches of the height of the 1852 flood. And this time we didn't drop the gate because now we have the National Park Service protecting our historic artifacts. So instead, we put hollow metal beams in front of the gate, and they worked the same way. in slots that Francis had built. And once again, the city was protected. And this is a view from the dam in that flood. I wrote my flood section of this book on a stream in Pennsylvania that normally flows at 250 cubic feet per second in June. So I was sitting there trying to envision the scene in Lowell in 1852. And then it started raining. And it rained for about 3 straight days. And all of a sudden, I noticed the water rising toward my cottage. And pretty soon, I managed to get the cars out, but no one else did. And everyone along the creek was trapped, and the water kept rising. And the flow rate went from 250 cubic feet per second to 40,000. The average flow of the Merrimack is 7,000. And this is a creek in my backyard. So I spent 24 hours on the second floor, and I got a real view of the power of water. In 1876, Lowell was an enormous industrial city with a great many mills and some 50,000 people. And you can see here the Northern Canal and the promenade that was still in place. And you can see some of the trees, these dots for trees. But all of the great mill complexes eventually adopted hybrid power systems using both steam and water. Because if they wanted to increase their capacity for production, they had really used up the available water power. Also, they wanted to use surplus water, which wasn't available all year. So if the surplus water ran out in August, they needed some other power source that could fill in temporarily till they could go back to the surplus water. So they needed steam engines. And these steam engines were really important in actually promoting the use of surplus water. Steam could replace water whenever flow in the river was low, or it could work when there was a great flood, which is also a problem for water power generation. And the exhaust from steam engines could heat mills and assist in processes like printing and dyeing. But the problem here is obvious, that we have coal smoke, which is very unhealthy. And you can see the air pollution that resulted from the development of extensive steam operations in Lowell. Now, this is a view of the Northern Canal with some of the graceful elm trees that Francis had planted in 1848. None of these trees survived the ravages of Dutch elm disease in this century. Also sadly missing from this landscape, from the landscape now, is a tree that Francis saved. If you look over here to this side, you see a kind of unruly tree, and that's a hackberry. And that was threatened by a road expansion. And Francis wanted to save this huge hackberry, so he froze the root system, picked the entire tree up, and moved it to the head of a row of elms and replanted it. He really wanted to spare that tree. So that by the early 20th century, Little Canada has really taken over some of the land that was used for the mall and the promenade. And we now have triple deckers along the Northern Canal. The corporations of the early 20th century no longer felt it necessary to provide costly amenities for a labor force that was increasingly made up of immigrants. So they were willing to give up the landscaping that Francis had taken such care to develop. But downtown, the parks survived along Dutton Street. In this 1909 view from about 1909, you see the downtown parks. The city took over the park along Ann Street, which is this one here, in 1909, and they hired the Olmsted brothers to develop a landscaping plan for it. Dutch elm disease was devastating, but the Lowell National Historical Park has put disease-resistant species in their place, and it takes good care of this ancient ash. And I think this ash is the last living link to James Francis and his tree-shaded canal system. I know that the national park is in very good hands, and that it's a wonderful asset for the city of Lowell. And I hope that you all will continue to support it. Thank you. A later period, about the mid-19th century, but it shows the particular canal development that was used here, and which I think influenced Nathan Appleton. That is that there's a dam, there's a power canal that runs from the dam downstream parallel to the river. And between the power canal and the river, there are a whole series of mills, multiple mills, all being driven by this one power canal. This was the largest water power site in Britain, but Lowell would make this site really look minuscule. Waltham was the testing ground for the later industrial development in Lowell. Mills built in 1813 and 1817 for the Boston Manufacturing Company were on a power canal that was parallel to the river. This plan was similar in conception to New Lanark, and the success of textile operations in Waltham led to a search for a manufacturing site with much more water power and with room for development. So these are the two mills. You can't see the power canal, but it's running in front of those mills. And here is the dam and the falls on the Charles River. But this was a site that really had inadequate water power. Not very far away, however, was a site that had much more potential. The great city of Lowell exists because of the Pawtucket Falls of the Merrimack River, which are 27 miles from Boston, as you all know. The falls had the potential to produce almost 10,000 horsepower year-round, and there was a drop here of some 30 feet. Pawtucket, or more properly East Chelmsford, Massachusetts, was the site of colonial farms and small-scale mills. The falls were spectacular, but they seemed impossible to harness and hindered transportation on the Merrimack River. In 1796 and 1797, the proprietors of locks and canals built an artificial waterway around this sharp drop on the river. And you see the rapids here, which are still in place, and the falls were really jagged rocks. And for a change in the operations in Lowell. In 1825, the Merrimack Manufacturing Company decided to sell land and lease water power to other corporations. In 1824, they were still thinking about expansion and perhaps considering operating all of the new mills themselves. But they decided that they would set up the old proprietors of locks and canals as a land agent, construction firm, machine builder, and leaser or lessor of water power. And they were going to be leasing water power to other corporations. And the first sale was to the Hamilton Manufacturing Company. And this plan represents the ideal layout of mills, but on a relatively small scale. So we see a drop created here at the swamp locks, which would be a 13-foot drop, from an upper-level Pawtucket Canal to a lower-level Pawtucket Canal. And we see a new power canal, which would be called the Hamilton Canal, which would feed an entire set of mills, both the Hamilton Mills in 1825 and the Appleton Mills in 1828. And we also see the planning for boarding houses, which would be across the canal. So this was a rational layout. We also can see their plan to constrain the rather unruly Pawtucket Canal and to ideally narrow it down to about 60 feet wide and 8 feet deep. So this ideal system involved two levels. And Chuck Parrott produced this drawing for me to demonstrate the two-level concept. And I think this is the first time someone's produced a schematic that's easy to understand, that shows you how the two-level system works. Essentially, you bring the water through an upper-level canal, which is carrying it at the same level as it would be in the mill pond above the falls. You bring that to the first mill.
We have with us today Dr. Pat Malone, who is a professor of urban studies and American civilization, and he's director of the Urban Studies program at Brown University. He is co-author of The Texture of Industry, an Archaeological View of the Industrialization of North America, and he is author of The Skulking Way of War, Technology and Tactics Among the New England Indians, also published by Johns Hopkins. So they gave me that in fine print, so I did the best I could. Sorry, Pat. Anyway, all of us who work at the National Park on issues dealing with the Lowell Canal system constantly use Pat's work as a reference and a guide, and he's been called more than once for some advice on one arcane issue or another. So we are very pleased to be supportive of Pat's new book, and glad to welcome him to speak to us this afternoon. Pat Malone.
Well, it's certainly a pleasure to be here at Lowell. Many of the people in this room actually helped me with this book, and I think it's really appropriate for me to kind of kick off the campaign for the book with a talk here in the National Park. This is the book published by Johns Hopkins University Press, and it's available in both paperback and hardcover. The idea for Lowell may lie in a utopian plan by David Dale and Robert Owen for this community, New Lanark in Scotland. Nathan Appleton saw this model industrial community in 1810 while he and Francis Cabot Lowell were both in Britain. And the whole idea of New Lanark was that an attractive and comfortable environment would actually improve worker productivity. This is the map of New Lanark at a somewhat canal on the river. They then formed a new corporation, the Merrimack Manufacturing Company, to manufacture textiles. And they placed its first mill to use the full drop of 30 feet. So they're putting that mill over here, and they're going to use this transportation canal to feed a series of power canals. The Merrimack Manufacturing Company, with this full drop, had what they considered an ideal location. But they had plans for up to 60 mills in all. So this is really going to be an enormous transformation. This particular image came from the Center for Lowell History. And this next map came from the Lowell National Park collection. This is a map of Lowell in 1825. Chuck Parrott, who's here today, was co-supervisor with me of the Historic American Engineering Record survey in Lowell. And we discovered this map in the basement of the Boot Mill and in the operation that was then known as Boot Hydro. And this is a map that conveys the canal system, not only as it was in 1825, but as it would be in all of the construction that was planned for the immediate future. And in fact, it took them until 1836 to complete all of the canals. The falls are here, the Pawtucket Canal is here, feeding this network of power canals. This planned system is not the simple parallel plan that we saw at Waltham, and we would see later at Lawrence. Instead, it makes use of this existing Pawtucket Canal, and it ends up with a rather complex network of water power canals on two levels. In 1824, just before that map was produced, they had begun to tentatively plan rapids. Industrialists known to historians as the Boston Associates gained control of this failing transportation canal in 1821. So the Pawtucket Canal, which the proprietors of locks and canals had constructed as a way to go around this obstacle, was not doing very well by 1821. And these new industrialists, these investors who we call the Boston Associates, quickly turned the old Pawtucket Canal into a feeder for a system of power canals that would serve industry. The concept, I think, is really visible here. This is Cohoes, New York, and the falls of the Mohawk River, where there was a dramatic drop of some 80 feet. And Lowell was really an inspiration for the development of Cohoes. But here we see all of the water diverted. So here is the falls with nothing going over it. And instead, the river is being diverted into a power canal. And the water is staying at the upper level above the falls. And it's then being taken a considerable distance downstream while the river continues to drop, giving you even more potential power. And finally, we see mills in the distance. So this is the same type of concept that the Boston Associates hope to use in Lowell. In 1821, the situation in this area was shown on a map by Hales. And this particular map identifies the falls. You can see the Pawtucket Canal, which goes around the falls and into the Concord just before its junction with the Merrimack. And there's also an interesting feature on here. There's a contour line, which is the height of the river above the falls. And that's really important in the planning of the mills that would be put in place here. The Boston Associates secretly bought most of the land between the Pawtucket